Yeah, thanks very much, Adam. Greetings, everybody. Been a great 2-day conference, and it's good now to have a very experienced panel talking about how digital twins sort of move into the maintenance phase. We've seen how they're great for being used in design, during construction, pre-commissioning, and operations, and now a very important use to do a better job at maintenance. So I'd like to circle through the speakers right now and get them to briefly introduce them. You've heard some of them in previous sessions. So let's rotate through. Daniel, could you introduce yourself?
Yes, hello everyone. This is Daniel.E.Viassolo. I work for Schlumberger. I'm a data science manager. I'm principal scientist. I work for the well construction division. I'm based in Houston, Texas. My scope of work is about predictive maintenance for some of our tools. And very happy to be here in this panel. Thank you.
Thank you, Daniel. Marcio.
Hello, good morning from Brazil. Thanks, this is Harta. It's a pleasure to be here today. My name is Marcio Wagner da Silva. I'm process engineer and transfer and storage manager at Petrobras, based in São José dos Campos, Brazil. And my role is to work with the operations and transfer and storage crude oil derivatives in the Henrique Large Crude Oil Refinery. And it's a pleasure to be here today. The digital twin and predictive maintenance is a hot topic in the downstream industry nowadays. It's a very, very important topic. Thank you.
Okay, next speaker is John Glen. I don't think he needs too much introduction because he was on the previous speaking slot. John, welcome.
Thanks, David, and hello again to everyone. So John Glen, CFO, co-founder of Spartan. I'm also the product manager for Profis, which is our predictive analytics solution, which we designed for the oil and gas industry. Looking forward to working with the panel. Thanks, David.
Okay, and our final panelist, Otavio.
Hello, everyone. Hi, Marcio, Daniel. Hi, John, my colleague from the last Future Oil and Gas. Nice to talk to you again. My name is Otavio. I am a mechanical engineer. I have master degree in metallurgical and materials engineering. I've been working with asset integrity management, corrosion, and technologies applied to this knowledge field for the past 10 years. I'm founder of and CEO of Vidya. Our business is engaged in the digital transformation of the industry, especially process industry and oil and gas. We are creating value for the operation and maintenance of industrial plants such as oil and gas, both in upstream, midstream, offshore installations, as well as mining, petrochemical, and other process plants using digital twin. And we are employing digital twin for asset integrity management, including software platform, artificial intelligence, analytics, and so on. It's a pleasure to get this opportunity to bring our insights here and share some knowledge. Thank you very much.
Otavio, where are you located right now?
We are in Curitiba, Brazil, South Brazil.
Oh, okay, great. Well, we've got some three of our people then. Three of our people are in early morning, so thanks for joining us. So, let's go through the first item for the panel was how a digital twin might support preventive maintenance by reducing downtime. Daniel, what can you share with us on that?
Yeah, sure. Actually, this is one of the main applications for a digital twin for us. Supporting predictive maintenance to reduce downtime. So downtime is mainly due to there are several reasons, but a big reason that we are trying to hedge about this unscheduled maintenance, right? Unscheduled maintenance is expensive because it is unplanned, right? So the digital twin is used to predict failure, doing prognostics, doing prediction of failure, and manage the system health such that we can plan our maintenance around, right? So as much the digital twin is one of the main components in our strategy to try to move as much unplanned maintenance into planned maintenance, right? Because this is where we can really lower costs for maintaining our tools, our operations in general. So I would say that's the way we are using, or one of the main ways we are using the digital twin to support predictive maintenance is to having the digital twin host models to predict failure, right? Yeah, so that's what I can say about this item, I guess.
Okay. Marcio, you mentioned you're in the transportation and refining. Have you been able to use digital twin predictive maintenance to help reduce the downtime there?
Yeah, nowadays in our crude oil refinery, we basically apply the digital twin to optimize and do better decisions on our crude oil process units like delayed coking, catalytic cracking, and crude oil distillation. But I understand that the digital twin have a higher potential. I totally agree with Daniel with the potential of the digital twin to the maintenance and predict maintenance. For example, I believe that the digital twin can be used in combination with IoT devices to monitoring and to indicate the real necessity of not only the planet maintenance. For example, in the crude oil refinery, we define a scope of the operational campaign to make a planet maintenance stop. And I believe that the combination of digital twin with IoT devices in each equipment, especially the dynamic equipment, can be possible to do the only necessary. So I understand that the digital twin have outstanding potential to reduce the operating costs in the crude oil refineries, not only in the downstream sector, but the whole industry.
Good. Thank you. John, have you, do you see people using digital twins with preventive maintenance sort of on its own, or are they linking this into their enterprise asset management or computerized maintenance management systems? How does that work?
Yeah, you have to integrate. I don't think this technology will ever really work and deliver the value unless you have an integrated approach, collaborative approach, in my opinion, David. And so our experience has been, obviously you need to take data from multiple sources to build the twin. So typically it could be your historian, your maintenance management system, your production loss system, P&ID diagrams, a small subset of data required to build a good predictive maintenance twin. So there's definitely input required from other parts of the ecosystem to build the twin. And then the twin, in terms of a predictive maintenance use case, only adds value to the company when you intervene before the downtime event happens. There's no point having predictive maintenance if you don't intervene. So you also need to integrate into the operational workflows, and you may have to almost certainly invent new operational workflows to take advantage of it. So, for example, a dry gas seal failure is predicted in your gas compression system. It's got a 48-hour window to intervene. How do you get from that prediction to an actual intervention? Well, you may first of all have your experts analyze it and validate that the validate that the prediction is in their opinion, worth acting on. And then you've got to create an action path from that prediction to an actual, possibly a hands-on engineer offshore with a wrench interacting with the equipment. And I think managing that workflow and using open technology, APIs, etc., to make sure that workflow is as efficient and simple as possible is really important. So yes, this is part of an ecosystem, and you have to look at it in the whole. In their experience, David.
Yeah, thank you, John. I like the comment about being part of an ecosystem. How things can collaborate virtually as well as with the people. Otavio, have you seen ways that people have used these tools to reduce their downtime?
Yeah, sure. I agree a lot with John said. Just to contextualize here, predictive maintenance, for example, for rotary machinery or in electrical motors, will rely on monitoring of vibration, for example, temperature or electrical parameters. And the maintenance execution, strictly speaking, it will involve multidisciplinary teams, such as electrical teams, mechanical teams, instrumentation teams, and so on. On the other hand, if you take another domain, predictive maintenance of, I don't know, structural components, for example, the parameters will be others as well as the team and the expertise. So, which means that the prediction or predictive maintenance is highly dependent on the maintenance domain and the knowledge involved. So you need to achieve a balance, a trade-off between the parameters you are monitoring, the maintenance jobs you need to run, the operation condition adjustments you're gonna do. So let's think about an industrial facility where all those different components are working together, sometimes interdependently, and we can even find some overlaps or influences between one and another in some applications. So in my perception, a well-designed digital twin in terms of asset data, operation data, maintenance workflow, or historical data, a digital twin that is focused on the value, the use case, or each domain you're employing it, is the enabler technology is capable to deal with all this universe of variables interacting in this complex environment. So it is capable to play a central role in predictive maintenance management.
Thank you. Very good. I wanted to remind our viewers, the participants, that we've got a section of the main conference online stage Q&A where you're able to type in your questions. So we've got a very expert group here of panelists. You can ask your very hard questions for them, and we'll see if we can fit that in. So I wanted to encourage you to drop some questions there, and we'll try to answer those. Our next topic was maximizing revenue and productivity through analytical-based operations, sustaining value delivery from analytics. I guess maintenance, if you don't do it the right way at the right time, can be very disruptive to our operations. We can lose a lot of value. So I was wondering if the panel could share some examples of maybe how people saved money and kept operations going by using these tools. So Daniel.
Yeah, so something I can say from my own experience is that we've been using digital twins to keep track of the health of different assets.
Okay.
And for example, you hear me? Yeah.
Yes.
So, and for example, so keep track of the health, as I said, of different assets. And for example, pair the asset failure, risk of failure with the job demand level, right? So we make sure that a healthy asset go to some of the most demanding jobs, for example. Also, something we've been doing is we keep track of special equipment that are being added to our assets, to our tools. For example, some tools are being ruggedized for some environments. So that's the way we keep track of a level of ruggedization, let's say. Also, again, this is, in my opinion, this is also, of course, connected with the previous topic, right? We talk about downtime, and productivity has to be, or part of the productivity has to be with lowering the downtime. And for that, again, using the digital twin for prognostics or diagnostics is key there, right? It's a key function of the digital twin in our entire workflow to support productivity. Yeah, that's pretty much it. Thank you.
Okay. Thank you, Daniel. I want to say hello and introduce Dr. Rabello Samuel. Welcome him to our panel. Dr. Rabello, I wonder if you could give a brief introduction to yourself. And we've talked about how digital twins can support predictive maintenance with reduced downtime and help deliver some more value. And wondered if you had a couple of points you could contribute, some insights on these two aspects.
Yeah, thank you, Dave. A brief introduction. I'm with the Halliburton last 25 years and in the industry 36 years. I'm more on the well engineering side and more recently on digital twin and automation, robotics, and more on the cyber physical system. It's a brief background. Now, to answer your question, the technology is cool, but how do we translate into the top line and bottom line KPIs are important. To the previous speaker, I am in alignment. We track some of the tools when in operation so that we can take remedial action as it is being used. So now, as I said, the technology is cool, but how do we bring value and reduce the downtime? In that, the digital twin definitely plays an important part, and also it includes an uncertainty overlaid with that. Now, we can connect the digital twin to the physical world, but what are the analytical models under the hood is important. It is not just duplicating a physical twin on a tool or an asset, but it is important that we connect and update the digital twin and make it as a live program. So an added example is as the well is drilled, I'm very specific to upstream in the drilling operation, different tools are run. We not only track at the surface what it has done through using the digital twin, but also as the well is drilled, we update it in such a way that we not only provide the preventive analysis, but also take into a prescriptive analysis. That brings value. It's not only the failure of parts, but also the operating conditions under which it is being taken for operation.
Yeah, thank you. A very good reminder when we're drilling a well and you want to monitor what's happening to your bit, and when you have to run in and out of the hole. Tremendous savings are possible there if you're keeping a good eye on all the variables. So moving on to Marcio. Marcio, just sort of continuing to build. We were reducing downtime. We'd like to deliver more value. How have you seen that happen?
Well, I understand that the digital make our life more easy to identify the separation point of the, for example, our processing units. An example for is the fluid catalytic cracking units, and the model, an adequate model of digital twin can offer opportunity to determine the economic point to operate the unit, and this information can direct our mine efforts to keep the reality and to make possible this keep the unit in this point. So reduce it's necessary to make a balance with the economic point and the reliability of the unit. This can help to determine the really best operation point in the physical plant. So, including the downtime and the we earlier in the planet maintenance window, we can direct our maintenance effort to do only maintenance to return the process unit in the operation campaign.
Okay, thank you, Marcio. John, how have you seen people extract more value here?
Yeah, thanks, David. Well, I think the value for predictive maintenance is actually quite clear, which is good because it's not often clear with artificial intelligence, given how early it is. But I think obviously the other panelists have mentioned, reducing lost production, increasing the yield, basically, reducing operations and maintenance costs, and the third one, which is beginning to come into focus, is CO2 emissions. I read a McKinsey report that I think 10% of industrial emissions come from upstream oil and gas. So anything we can do to reduce CO2 emissions is obviously very important too. So given that, I think there's a very clear value case. The question is, how do you tap into that value? So we completed a pilot recently with Repsol Sinopec in the North Sea on the Piper platform, and really it was about starting with the fault modes. Which fault modes lead to the most downtime, and triage the fault modes, and then from there you can decide, okay, which plant and equipment boundaries are contributing to these fault modes. So that's a logical conclusion. And then you build a digital twin for those instances of plant and equipment. And then you work with the users to build a series of models, be it expert rule, white box models, or black box labeled models for machine learning. And then the most important part is to put it into action. So a prediction is made, the experts have to collaborate and analyze and make a decision. And if the decision is made to intervene, then, as I said before, you want a seamless workflow to perhaps raise a maintenance work order automatically the back of that prediction, so that someone offshore can go hands-on and resolve the issue before it happens. And we've also worked with mobile workforce, so the kind of digital worker model, where when the work order is raised, for example, it's immediately available on the mobile device. It's linked to the permitry system, so they know when they can actually go and access the equipment safely. And then they do the investigation work order, they complete that, and then that information feeds back into the twins, so that the people in the onshore control center can actually see what's happened offshore, see how it's affected the twin, and validate it. So these are real world use cases that we've implemented. This is no longer science fiction. And what we need to do is prove the model, scale it up, and get that return on investment back to the leadership team. So I think someone said yesterday, I think the technology at the moment is slightly ahead, actually, of the organizations and the people. So I think we just need to get the people and the organizations in line with the technology, start to implement these solutions and start to really see the value from them. So I think there's a lot of value there. We just need to go on and tap into it now.
Thank you, John. Otavio.
Okay.
How have you seen value?
So, yeah, I would say something about to bring value and bring return on investment on a digital twin project. But we understand that before discussing value, we must have in mind three premises on digital twin initiatives. Well, first, a digital twin can have a super wide scope in a process or in an industry, if you want. Second, a digital twin will depend a lot on what the end users have first in terms of data and infrastructure and everything, and what he really wants or he really needs. And we must have in mind that the digital twin can be phased in partial deliverables. So we can start by creating a twin with physical attributes, 3D or visualization or representation of the asset. After that, in the next step, we can create a data input workflow to the twin, create the AI running over the digital twin using machine learning or some algorithm or simulations. You can run analytics, and after that integrate with other systems. After that, bring some kind of optimization in your process and even control something using the digital twin. So you have a lot of phases. So whether or not you must start a digital twin project to bring value to the client or to the user or to the people involved with a pretty well defined POC at first steps, I believe, with a well-known and limited expected results agreed between the parties involved, between the technical guys, the users, and the technical partners that is deploying the technology, and a well-defined scope. After that, you will kick off a digital twin journey. You will guide the investment in time and cost and upgrades that you're going to do in the project. And this only open a world that is much more than an application. Digital twin could affect transversally the operation or the companies itself. So this is my vision on how digital twin can bring value.
Great. Thank you, Otavio. Dr. Samuel, the next topic we had was driving the appropriate data model. And I guess one of the things that we've heard over the course of the conference is we've got physics-based analytical models that give us data. We've got machine learning that is using real field data and everything. How do we sort of merge that idea? Which kind of data from what kind of analysis do we want to use to help us with predictive maintenance?
Yeah, it's an interesting question, Dave. Now, the basic simple method is if we cannot touch and feel the data, then it becomes a highly uncertain system. There are two cases. One is where you can measure all the things at the surface, whether it is a predictive maintenance or tool maintenance. The other one is when in actual operation. So the digital twin, now there are different methods, right? The mathematical methods under the hood, all these things are good. Now using a hybrid approach is the best way to do it. What we are doing, because a lot of things we don't know what is happening. So now if it is a highly uncertain, non-Gaussian stochastic system, then we have to go for a hybrid approach. So the hybrid approach, I think one of the speakers, I presume John, talked about the white box and the black box approach. We need to have a ratio. How much black box, 20% and 80% physics-based, so that we have a strong underpinning to that. In that, when we do a particular maintenance, whether it is a factory-based approach or a sensor-based approach, it has some DNA, right? That we have to fingerprint it based on both approaches, hybrid approach of using physics-based model as well as data science. Then you can overlay all this machine learning, AI, artificial deep learning, all these things. That will be handy. That we have a very good understanding. So as we traverse through this problem, I think the best approach is the hybrid approach. And I will add always an uncertainty analysis over it. That is my quick thought on that.
Great. Thank you. Daniel, data models for preventive maintenance.
Yeah. So that's a very interesting question, and I was listening very carefully to what Dr. Robello of Samuel was saying. I think if you talking about the models, right, and how to mix physics-based with database models, I think obviously to me it's obvious that the more physical insight you can have on your models, the better, right? So everything that you know physically, where you can put your SME knowledge around, you should try to leverage that, right? Don't leave that without use. What happened there is that many times you are able to know the let's say the structure of the model, but you need to fine tune model parameters, or you need to put some layer of machine learning on top of that, doing something hybrid. So I agree. Many times is the best solution is the best path is that path to put to start with a physics-based models and put your SME knowledge as much as you incorporate SME knowledge as much as you can, and then on top of that fine tune with data that you obtain from the field, right? That's my take on the data or model side inside the digital twin.
Thank you. Marcio.
Okay, thank you. I totally agree with Mr. Diazolo, but data is the base of any transformation effort of any industry, and in the maintenance or in digital different. But I understand that we need to put the focus to control the quality of this data. There is a way to follow to transform the data and information and knowledge, and how we can treat this data is strictly related with the quality of the effort, for example. Understand that the industry or the crude oil industry, for example, in my case, we need to understand and respond what kind of question we can respond. We want to respond. So the base the database model to construct an adequate path through this reflection. What kind of data we want, and this drive our effort to treat this data. And for example, we can improve the operational plan of the unit. What are the really very to read? So I believe that this, as quoted earlier, the data is the base of the digital transformation effort, but we need to think what's the objective of this data, and to another program this data and answer and finally our question.
Good. Thank you. John, physics-based, data-based, machine learning, how does that all work together to get preventive maintenance?
Yeah, I think I very much agree with Dr. Rabello, Samuel, in terms of his approach. I think the hybrid is the only way forward. We have a very narrow view of a digital twin when we're implementing predictive maintenance. A digital twin can be a very broad concept, but we are extremely narrow, arguably. So, for example, at the heart of our twin is the time series data that was generated from typically a historian such as Ozzy Soft Pi. So we want a time series, and that gives us, the raw material for a twin. And then we layer on top of that operational context. So the CMMS records, the maintenance records, the production loss records, P&ID diagrams, so 2 or 3 other data sources layered on top of that. Then we engage with the end users, the actual subject matter experts, and again we layer their operational knowledge on top of that, which will produce either labelled instances of faults and normal operation or a series of expert rules, at which point you're now ready to go into the build phase of a predictive maintenance project, where you will, in our experience, start with white box expert rules to get up and running and get something there that's quick and explainable and builds trust and builds confidence and gets you return on investment. And in parallel with that, start to investigate black box deep learning models for particular faults that are causing particular downtime. So if you've got a fault that causes millions of dollars of downtime, and it happens frequently, you may want to invest in deep learning to look at that particular fault mode. So, I mean, I think, is it 80-20, white box to black box? I think it's too early to tell. I think that's not an unreasonable starting position for it from a hybrid model, but I do think the data models for predictive maintenance, if you're selfish and just narrowly focus your twin on predictive maintenance, are actually fairly well understood and can be quickly built. I think we can, I'd say, 2, 3, 4, 5 days should be enough to build a twin for the key components of a platform and let you move on to the next stage. So I think this is almost a solved problem, in my opinion, and in our experience.
Yeah, that's great. Yeah, nothing stops us from in a hybrid world to have special versions of your digital twin for specific application. Otavio, what can you add?
Yeah, I totally agree on the dependency of your digital twin on the application, on the value you're gonna bring for each initiative, and I agree with John as well. That we must do it. We must deploy a digital twin project step by step, piece by piece, delivering this value and increasing or incrementing the technology in a hybrid way with several other a stack with technology, with models or workflows or technologies or integration with other systems. But I believe we can separate how we see the data flow and what kind of data we need and the precision or accuracy of this data in 3 parts in the digital twin. The first would be the model itself. We can create a physical model with physical attributes, with data sets you come from the engineering, create, a 3D environment to deliver some results, some boundary conditions. Also, in a second perspective, you can evaluate the input data, the data you can fed to the model from sensors, for example, from 3D imagery or scanning, or even field data acquisition using mobile devices, as John said, for example. And finally, you must evaluate the data, the accuracy of the data, or how you're gonna balance the precision of your models on the perspective of the outputs. The simulation the digital twin is capable to deliver, the predictive models you run, the optimization models, for example, or if you have a planning tool, for example, you can analyze how it's gonna run in terms of accuracy, in terms of data structure and everything, and how it's gonna interact with other parts of the project. Let's take an example here. We are running a digital twin for corrosion evaluation, looking to protective coating, maintenance, and structural analysis as well, where the 3D data, the precision of 3D data have an important role, because we need to identify where, classify corrosion, where, map the defects in the plant. However, our time series that results in the model, the predictive model on corrosion levels, for example, doesn't need to be an hourly based time series. Luckily, corrosion doesn't grow that fast. So I understand that the actors involved in the project, in the digital twin project, must find the best trade-off between how you're going to structure the data, accuracy of this data, the models you're going to use, tools you're going to use, and the most important, you must look at the value, and it cannot impact negatively the cost or the viability of the project.
Okay, good. Our last topic for the panel was predictive maintenance replication, automating for scale. I guess everybody always asks about the business case, the economics of creating a digital twin. And so one of the obvious questions is, we've gone to all the trouble to make up a digital twin with some kind of data model that we've just been talking about. How can I replicate that across multiple pieces of equipment, similar equipment, maybe across multiple facilities, multiple drill rigs? How can some of these kind of models be scaled up and applied multiple places? Dr. Samuel.
Yeah, that's the question may look very simple, but very complex. When you think about scaling up, it is always a difficult effort across the organization. So when you think about a virtual factory or digital twin, digital thread, and it becomes very complex. Right now, we have a lot of uncertainties. I use a simple formula. So digital scaling up or the digital transformation is equal to the technology to the power of exponential thinking. So we can have all these technologies and we have programs, plans to scaling it up. If you don't have any exponential thinking, the company will remain flat, or the initiatives will become just a follower of technology, or it may be very slow. Right, adoption becomes very problematic. So one is human element, the other one is the technology. So we have to use both at the same time in scaling it up, so that we have a live thread which are going across the organization that will bring value to the organization. Otherwise, always look for the bottom line or top line movement, right? So what is the return on investment that we are going to get? So the one issue is training the workforce, the minds. The other one is machines. So we have to connect both machine and mind. That is an important thing that will easily scale it up to the enterprise level. Otherwise, we'll fall flat. We can have all the digital twin in the world with all this hybrid approach and other things. It may not bring practical value to the organization or the business value chain.
Good, thank you. Daniel.
Yes. So, as you said, David, scaling is something that is crucial, right? Because there is a big investment of time and effort and a big effort in the company to create something like maybe a digital twin for a asset or process. And then we cannot use only for a particular application in a very small corner of the company, right? We need to be able to scale it up and make sure that we leverage that investment later on. So a couple of comments here. So the scaling has to be part of the planning pretty much from the beginning in the digital twin development, right? We cannot neglect that. We cannot leave that for a later phase, right? Has to be at the beginning. We need to think that we are going to do something to solve a particular problem, but there are going to be many other problems that we need to cover with the same technology as much as possible, right? Otherwise, the return on investment over time is not. It doesn't make sense, right? It doesn't add up. For that, what I found is that looking at creating some type of frameworks for the digital twin that take care of, for example, the interfaces with the data, the interfaces with the user. It's very valuable because we can focus more on maybe on the modeling side and less on the interface side, and that's a good way to scale up. There are also there is something to take into account is the deployment of these models, right? How easy are they to deploy? So a framework of some kind. I mean, it makes sense to invest a good amount of time thinking about that at the very beginning of the project. That's my main point, because otherwise the effort is too much usually for just one-off, right? One-off solution.
No, I agree with you. Thank you. Marcio, have you been successful with some of the efforts to scale some of these tools across multiple pieces of equipment or systems or facilities?
Well, in our we are embryonary program of the digital twin. As quoted earlier, we use the digital twin to make decisions related to the optimization of our processing unit. But I understand that the scale of the digital twin to physical plant is a crucial moment to the investment. But this is the real return of over investment, and is strictly related with the quality of data that treated to construct the digital model. So again, we need to define steps in the project of digital twin implementation to verify the of our variables and the digital twin model with the physical plant to earlier to the data, and believe that this is a critical moment, but this moment is related with the quality of the data applied to the model.
Okay, great. Thank you. John, how have you maybe helped some of your clients scaling some of these tools?
Yeah, it's a really good question. I think what I would say is that building the twins for predictive maintenance, I think I mentioned this before, is actually straightforward. I think you can build a twin for a platform in days or weeks, not months or years. So I don't think building the twins itself is the rate limiting step to scalability. And equally, the latest kind of generation of platform software as a service, predictive maintenance solutions based in the cloud, you can very quickly scale up the actual technology itself. So I don't think that's a particular big issue. I think the major issue to scale up of this technology, apart from the people, which is such a big topic, I'm going to put it to one side. But in terms of technology challenges, the biggest issue is the models. Building the models is actually the hardest part. And again, that's where the hybrid approach, I think, can come to a rescue. So I think if you build a white box model, an expert rule system, for example, you can transfer an expert rule for a gas compression system from platform A to platform B. And actually, it's highly transferable. You can tweak a few parameters in terms of pressures or temperatures or flow rates, whatever. But you can take the same model and transfer almost cut and paste to different platforms if you've got a network of platforms in your operation. But what we found is with deep learning, with machine learning, because, and again, take a gas compression system, it's probably the size of my house, and it's fairly, not fairly, it's very bespoke to that platform, how it's been configured. And if it's a brownfield site, it's been in place for years and years. The model that we build for that gas compression system on that platform will almost certainly not transfer to any other platform in our estate. So you have to go retrain and rebuild the deep learning models. So again, that's why I think the hybrid model is the right approach, and why deep learning is really important, but you have to consider it carefully before you use it. But I think the key to scale is to use the physics-based models first to get it across all of your critical plant and equipment across your estate, and use that to build up a return on investment and prove to the team that this technology works, and then use that success to cherry pick the asset, the plant and equipment you want to do deep learning on, because that will take a little bit longer and will cost you a little bit more time to do it. But you should get a return on investment in that as well. So I think there's a layered approach that can get us there, but I don't see any major impediments to scalability at this point, apart from that one caveat.
Okay, great. Otavio, scaling. Have you had some success with this?
Yes, I understand the joint points. We're in terms of technology, scaling technology or models. It's a hard task to do. An example here, we are training a model to detect corrosion and anomalies using machine vision, and for one situation in one kind of economic sector, or I don't know, one application, we have some results, and it's not we cannot replicate this model to another situation. I don't know, I'm training my model in mining, and where there's a lot of dust and a lot of one kind of corrosion, I cannot replicate to an offshore installation where everything is okay in terms of dirt, but we will find another type of anomalies. This is hard. We must have it in mind, the technological problem, to replicate models. Again, step by step, deliver a digital twin project step by step will be a key or a normal procedure to do it. But I would like to mention the challenge in terms of cultural challenge. I believe if I could name a main challenge on digital transformation, looking to the digital twin perspective, is to create at the corporate level an environment that allows to get many different peoples and areas involved within the project, because the digital twin project won't benefit one, or won't be restricted to one or another partner. Normally, this kind of project will benefit the companies transversely. So we must look to the way that we design the project, starting small, but looking to the future, looking to how we're going to scale this project. We must look to the way we conduct the project using agile methodologies, for example, to cut the deliverables piece by piece. The way we assume and divide risks along the areas involved, and even the way we share the opportunities with the stakeholder within each digital twin initiative. That's my vision. So we have the technology side and we have the cultural side.
No, very, very good points, Otavio. We come to the end of our time. As always in these things, I echo what Adam says. We could actually spend a few hours on the topic, but it's been great to hear the contributions from you all across a range of the industry, and thank you very much. We weren't able to get to all the questions. I noticed some of the people were dropping questions in the chat system, which I just noticed, but hopefully we got some of your questions answered in the course of this. So I want to thank everybody. Muito obrigado to our friends in Brazil, and I'll pass back over to Adam now.